So if breaking up a natural monopoly is a bad idea, what can you do to address public policy concerns? Well, another approach is price regulation. But again, you have to be really careful about where price should be set. To show you what I mean, put yourself in the shoes of a public utility commissioner and tell me where you would set price in this regulated market for the distribution of electricity. This is a tough question, and the answer is C. You would set price equal to average cost. Now, this might seem counterintuitive. In fact, you might think that the best place to set price is where price equals marginal cost. At this point, price regulation would effectively simulate the outcome in a perfectly competitive market and therefore be allocatively efficient. But what's the problem here? The problem is that the monopolist would be forced to lose money equal to the shaded rectangle, which is simply price times average cost minus revenues. Therefore, at this point, the only way the monopolist could really stay in business over time would be to receive a subsidy from the government equal to its loss. Since this is likely to be a politically unattractive option, we've got to find a more feasible option. The more feasible option is point C. This is where price equals average cost. Under this scenario, the monopolist earns zero economic profits, enough to stay in business, but does so without gouging consumers. At the same time, as should be apparent from the figure, the deadweight loss is considerably smaller than under pure monopoly. In fact, this price equals average cost rule has been very important in the historical development of the U.S. economy. It has been used for decades to regulate prices in natural monopoly industries ranging from electricity, gas, and water to the railroads, telephone, and even cable TV. Still in all, if you learn anything from this course, you should learn that there is never any free lunch in economics, only hard choices. Because even though the P equals AC rule seems to solve a lot of problems with monopoly, it can also create additional problems. Take a look at this graph. It illustrates what is known as x-inefficiency, a concept first introduced by Harvard economist Harvey Liebenstein. Here's the deal. Suppose you are the chief executive officer of a regulated electric utility and your price is set by the P equals AC rule. What does this do to your incentive to maximize profits? Well, think about this. Under the P equals AC rule, you are basically guaranteed the recovery of any cost that you incur. In fact, that's why this type of regulation is known as cost-plus pricing. So do you see the problem? Under cost-plus pricing, regulated industries no longer have the incentive to minimize costs and therefore maximize profits. Instead, there is a perverse incentive to increase costs for the benefit of the executives operating the firm. For example, the x-inefficiency theory predicts that executives in regulated industries will tend to hire more staff, buy thicker carpets, build larger offices, and engage in more business travel than they otherwise would under strict profit maximization. In such a case, what do you think such behavior would do to the observed average total cost curve and the regulated price? That's right, it would raise the average cost curve and lead to a higher regulated price. Now, in the figure, the shaded rectangle is precisely the measure of x-inefficiency. It just means that firms are operating well above their potential ATC. Now here's the punchline. In some cases, it may well be that any increase in allocative efficiency achieved by regulating a monopolist might be more than offset by an increase in x-inefficiency due to cost-plus pricing. And there's another fine example of irony for Webster's dictionary. The broader point here is that monopoly and the appropriate public policy response raises many thorny issues. Let me leave you with one last issue before we move on to monopolistic competition. This has to do with the effect of industry structure on another key measure of market performance known as dynamic efficiency. Dynamic efficiency measures the rate of technological change and innovation in an industry. And obviously, the faster this rate, the better the industry will perform and the faster the economy will grow. The question then, first raised by another Harvard economist named Joseph Schumpeter, is whether monopolies are likely to outperform competitive industries in the dynamic efficiency dimension. The implication is profound. If the answer is yes, then perhaps we should just leave monopolies alone. But how would Joseph Schumpeter's argument work? Well, since monopolists are likely to earn a much higher level of economic profit than competitive industries, they will have much deeper pockets to engage in longer-term strategic activities such as research and development. At the same time, they will also have a much bigger cash fund with which to make investments to speed the diffusion of the technology. Of course, the counter-argument to Schumpeter is likewise interesting. For example, while the monopolist may have deep pockets to spend on developing new technologies, that same monopolist has little incentive in the absence of competitors to introduce the technology, so technological progress is actually slowed. By the way, my favorite example of this counterargument lies in the claim by some critics that the phone monopoly AT&T did indeed invent the touch-tone phone in its research arm of Bell Laboratories. Nonetheless, it waited years before ever bothering to introduce it because it faced no competition. At any rate, suffice it to say that we can't settle this debate here, but the debate provides yet an additional layer of complexity to thinking through the public policy implications of economic theory. With that said, let's turn to an even more complex beast, that of monopolistic competition.